Hey everyone, in this video we are diving into an amazing journey through the realm of AI. We are exploring 5 unique portfolio projects that span from beginner to intermediate levels utilizing tools like Python, OpenAI, ChatGPT and Langchain. So the first one in the list is the Plagiarism Analyzer. You might be wondering how plagiarism detection on textual data is done. Well, it ain't as complicated as you may think. Here is the source code for the project and you can find the link in the description as well. We all know that computers are good with numbers, so in order to compute the similarity between two text documents, the textual raw data is transformed into vectors array of numbers, and from that we make use of basic knowledge of vectors to compute the similarity between them. Let's quickly have a look at the code. So in the first part of the code, you have to import the necessary libraries, which are the TFID vectorizer and the cosine similarity, because we are going to detect plagiarism from the textual document using the cosine similarity. Then the next step is to read all the documents in the current directory which ends with the extension txt. These are actually the document inside which you want to check the plagiarism. After that, you simply have to vectorize your documents using the vectorize function and then find the similarity between the two documents using the similarity function. And then we have a check plagiarism function in which we are going to iterate through the list that contains a vectorized file and we'll look for the similarity using the similarity function. And then finally we are iterating through the data returned by the check plagiarism function and we are printing all the results of the plagiarism that were returned by the check plagiarism function. The second project on the list is PDF interaction with Langchain and GPT. In this project, you have to use the Langchain to create a ChatGPT for your PDF using Streamlit. This project creates an application that allows you to ask questions about a PDF document and get answers directly from an LLM like OpenAI's ChatGPT. So here is the code for the project. In the first part of the project, you have to install the necessary libraries that are not already present inside your Jupyter Lab or Jupyter Notebook. These libraries are Langchain, OpenAI, PyPDF2, FireCPU, and TickToken. Once you run it, it is going to install all the necessary libraries one by one inside your notebook. Then from the added packages, we are going to import the necessary libraries like PDF Reader from the PyPDF2, OpenAI embeddings from OpenAI, character text splitter from the Langchain splitter, and vector stores, etc. After that, firstly, we are going to set the environment variable for the OpenAI API key, where you have to provide the API key for your OpenAI account. After that, I am using the PDF reader to read my PDF file. You can provide the path of your file or give the name of your file if it is present in the same location. And once you are done with reading the file, you simply have to concatenate all the text which is present in all the pages of the PDF file into a new variable which is called raw text. And if you print raw text, then you can see that all the text present in all the pages of the PDF file has been concatenated inside a single variable. Now the next step is to split the text using the character text split such that it should not increase the token size. So you have to provide a chunk size. Here the chunk size is 800 and then use the text splitter libraries split text function and pass the raw text in it, and it is going to split your text in chunks of equal sizes. So if you print the length of the text, then it is going to show you that it is 149, which means that our document's text has now been splitted into 149 lines of text. Then we are going to download the embeddings from the OpenAI library and we are going to use its from text function and pass the text and embeddings to it to provide the document to be searched to ChatGPT, or in simple words, OpenAI. And then finally, from the Langchain, we are going to import the QA chain and we are going to import the OpenAI from the Langchain. Then we are going to load the QA chain by providing OpenAI and the chain type, which is stuff. After that, we are going to create the query which you want to ask from your PDF document. And then we are going to perform a similarity search of the query inside the document that contains our embedding of the text. And then finally, we are going to run the chain inside which we are going to provide the input document to be docs that contains a similarity search and the question which we want to ask from our file. And once you run it, then it is going to provide you the result of the query after reading it from the PDF file. And in this way, you can write different number of queries in different formats that can be asked from your PDF file and it is going to generate the response for you. The third project on the list is a multilingual translation tool. In this project, we are going to create a multilingual translation tool that is going to translate the text into multiple languages using the OpenAI Chat Completion API with GPT 3.5 Turbo model. So here's the code for the project. The first step is to set up your OpenAI credentials. So you have to go to your OpenAI account and copy the OpenAI API key and paste it here. The next step is to create a translation function. This function sends a message to the GPT 3.5 chat API instructing it to translate the text from the source language to the target language. And this will be done in the form of prompt, and just like ChatGPT gives a response to a prompt, here again we'll get a response of the prompt and we are going to get the translation from the response. Then the next step is to test the translation function. So before integrating the function in your application, you have to test it with some example translation. So let's say you can define the source language to be English, the target language to be Spanish, and then you can translate the text by providing the text source language and the target language and get the translated prompt, and then we are going to print it to see how is the response in the output. And in order to make it look good, the next step is to create a user interface. This is being done to make the translation tool more accessible. For this step, we'll use Python's Tkinter library and create a basic interface with the input fields for the text, source language and the target language, as well as a button to initiate the translation. And then you can simply run the project and test the user interface and the translated response generated by OpenAI's ChatGPT. The fourth project on the list is the GPT Voice Assistant. In this project, you will build your own AI-powered personal assistant just like Jarvis. Here is the code for the project, and in the first part of the project, you have to import certain packages which will be needed, which are OpenAI Whisper, the Gradio, OpenAI, TTS and Python.NET environment. You also need to install the NumPy. And once this is done, the next thing is to import the necessary libraries from these packages, and we are going to test how our Gradio UI looks like by using a simple grade function in which we are going to print hello with the name of the person. After that, we have the text to speech part. In it, firstly, we are going to list all the models from the text to speech library, and from that list, we are going to take a random model. And then we are going to use the text to speech to file function of the model, inside which we will pass the text and the file path of the output file. And then we are simply going to test the output file to see if it is working properly or not and if the text has been successfully converted to audio. Then we'll move towards the Whisper part, in which we'll get all the available models from the Whisper, and then we are going to load a specific model which is tiny.en to the model. And then for the ChatGPT part, firstly we are going to load the environment variables, and then we are going to set the OpenAI API key environment variable. Then we'll create a list having role and content, and then we have a function called ChatGPT API in which we are going to append this messages list to our messages, and this is being done to get the reply for our message. Then the next part is the function to transcribe, and it takes an audio, Whisper converts it to text based on the model we provided, and then the text is passed to ChatGPT. And then the response of ChatGPT is again converted to audio using text to speech. So here firstly it is going to transcribe our audio into text, and then that variable will be passed to the ChatGPT API, which is going to convert our text to audio. After that, we are going to use the text to speech to file function, in which we will pass our text file and the path of our output file, and then we are going to return the audio part, the text part and the output file. And then for the Gradio UI, simply we are going to have two text boxes and one audio part. The label of first one is going to be speech to text. The next one is going to be ChatGPT audio, and for the audio we are going to set ChatGPT output to audio via TTR. And there are different variables for making the interface look good. Actually, it will ask you to select or insert your prompt in the form of audio file. Then that audio file will be transcribed into text, and that text will be passed to ChatGPT. And once the response is generated by ChatGPT in the form of text, then that text file will once again be converted to speech and will be returned to our application and will be shown on the Gradio UI. And then last but not the least, we have the face recognition project. There are different folders inside the project having base models, comments, the detectors, extended models, and the files for all of these. But I am simply going to show you the deepface.py file, which is actually the main file of this project. In the first part, we are going to include different common libraries as well as the third-party libraries, and we are also going to import different libraries from the deepface.base models such as VGG face, OpenFace, FaceNet, etc. And we are also going to include the extended models and common models from the deepface library. After that, we'll quickly configure our dependencies, and then the first step is to have a function which is the build model. So this function basically builds a deepface model. It takes the model name as an input parameter and returns the build deepface model. Then next we have the verify model. This function verifies an image pair is same person or a different person. In the background, verification function represents spatial images as vectors and then calculates the similarity between those vectors. Vectors of same person images should have more similarity or less distance than vectors of different persons. And this function returns us a dictionary. Then we have the analyze function. This function analyzes spatial attributes including age, gender, emotion, and race. In the background, analysis function builds convolutional neural network models to classify age, gender, emotion, and race of the input image. And then it returns a list of dictionaries for each face appearing in the image. Then we have the find function. This function applies verification several times and finds the identities in the database. And as a response, it returns a list of pandas data frame. Each item of the list corresponds to an identity in the image path. Then we have a represent function. This function represents the facial images as vectors. The function uses convolutional neural network models to generate the vector embeddings. And as a response, it returns a list of objects. Each object has fields like multidimensional vector, the detected facial area, face detection confidence, etc. Then there is a stream function which applies real-time face recognition and facial attribute analysis on the image and does not return anything in response. Then we have a function to extract the faces. This function applies pre-processing stages of a face recognition pipeline including detection and alignment and returns a list of dictionaries. Each dictionary will have facial image itself, extracted area from the original image, and confidence score. So the major part of this project, such as the extract faces, the represent, visualize, and all the important functions are present in this file. So that is why I've gone through this file, and you can view all the files present inside the project in the GitHub repository that will be available to you in the description of this video. And these are the 5 unique and exciting AI projects that range from beginner to intermediate levels, all leveraging the power of Python, OpenAI, ChatGPT, and Langchain.